All right. In this video, we are going to talk about a special type of multiplication of polynomials where we are going to square a binomial. So these problems are like those in 12.6, numbers 19, 23, and 35. I'll generally give you a couple formulas here that say that a plus b squared is equal to a squared plus 2 times a times b plus b squared, and a minus b squared is equal to a squared minus 2ab plus b squared. These things on the right here are called a perfect square trinomial. I cannot emphasize how important it is for you to memorize these formulas and to be able to recognize this going both ways. So this video is going to focus on going from the left-hand side to the right-hand side, but in just a little bit, we're going to need to go the other way and take this perfect square trinomial and factor it into what's on the left-hand side. So we're going to be doing a lot of that when we get to pre-calculus as well, with a technique called completing the square. We'll do some completing the square also in the very last unit here of MDE 60. And this is the perfect square that we're trying to complete. This is not a video on completing the square. I'll get rid of that for right now. It is a video on perfect square trinomials though. So let's take our first example, x plus 7, and we're going to square it. Now I'm going to do it the long way first, and then I'm going to show you the formula way that works. So if I write this out as x plus 7 times x plus 7, and then I FOIL or double distribute, whichever you want to do, x times x is x squared, x times 7 is 7x, 7 times x is 7x, and 7 times 7 is 49. See how these middle terms are the same? They're always going to be the same. So that's where the idea of 7 plus 7 is 14, which is 2 times 7 comes in, right? So I could have started over here and in one step said it was a squared, which is x squared, then take these two numbers times each other, that's 7x, and then double it. That gives me 14x, and then 7 times 7 is 49, and I could be done in one step. So that's what this formula does for me, is it lets me expand this binomial squared in one step. So let's try to use that formula technique on the next one so that we practice that. We don't want to go back and reinvent the wheel every time. So let's now take 2a minus 7 squared. So 2a squared, it's going to be 2 times 2 is 4. A times a is a squared. 2 times negative 7 is negative 14. Negative 14 times 2 is negative 28. A, and 7 times 7 is 49. Again, if you want to see it out the long way, 2a times 2a is 4a squared. 2a times negative 7 is negative 14a. Negative 7 times 2a is negative 14a. And negative 7 times negative 7 is a positive 49. 4a squared minus 28a plus 49. I wouldn't be emphasizing this so much if this formula wasn't really important. So while you could write the squared out every single time as something times something else, that's not going to help you when you need to go the other way as much. So you need to get used to using the formula. So let's work on one more problem here. 2m plus 3n squared. It's going to be, and I'll write it out like this. That's my formula way. 2 times 2 is 4, times 3 is 12, m times n, plus 3 times 3 is 9, n squared. All right, so those are my 3 example problems from this section of the textbook. We'll come back next time and we'll start doing some factoring, which is a big part of this class. Probably the biggest unit in this class is on factoring techniques. So we'll come back and we'll start talking about the greatest common factor. And I'm going to use some factor trees to help you figure out what the greatest common factor is for some lists of numbers that we have. And then we'll also come back and talk about greatest common factor for a list of terms that have not only numerical coefficients, but also have variable parts to them as well. All right, we'll see you for the next videos.